So in the last question we asked what is the magnitude of a small dq that the B gonna feel at location B, but we know that the electric field, right, it's actually have some size and some direction, right? So we want to find, we find already this, and also let's talk a little bit about what is the direction of each one. And for doing that, I want you to think a little bit outside the box. I want you to look at the sum pattern. So if I have this charge here, Q, I know, let's take this picture here. So if I have this point B, and here I have some positive charge, right? So what is the direction that I expect to be of the electric field? I expect it to be going away, right, from this one. But for each charge that I have here, I know that in the same radius, in the other direction, I have the same charge over here, right? So this was dq, let's say, with some radius and some theta, right? And this one is another dq, which have the same radius, so same size, because the sigma was going like pi node r squared, right, in this question. So it's going to have the same magnitude, but in pi plus theta plus pi, which means 180 degrees, okay? And what's this going to do? It's going to also repel this place. And what we actually have here in location B, we have two vectors, right? This one and this one. So if I'm going to tilt this vector to this direction and this one to this direction, I see that they cancel each other in that direction. You see? Each vector has some angle, and boom, if I put it on this, in the horizontal plane, I'm going to see that some cancellation. But if I'm going to put the other part, I'm going to see summation. And this is true to every location, to every place, to any charge. If I'm going to do it in a different radius, for example here, and here, I'm gonna do this. I'm gonna see the same thing, or here and here. So this I'm gonna have from here some repulsion here, from here some repulsion here. This is gonna cancel this one. This is gonna cancel this one. But I'm gonna have some summation only upwards. So what does it tell us? It tells us that when the bee actually arrived to the flower, and when the bee feels only the electric field go upwards, she knows, okay, I'm on top of the center. I can go and dive down. So what actually we know that the electric field at location B is equal to some magnitude, but in what direction? 0 at x, 0 at y, but only in the z direction, right? So we already know what is the direction of the electric field. And I want you in the homework always to try to understand, before you solve the question, what is the direction of the electric field, where it's point. Okay? So perfect. Let's go to the next question.